Hello everybody. In this lesson I'm going to be showing you how to apply the empirical rule for the normal distribution. So let's look at an example. For males in a certain town, the systolic blood pressure is normally distributed with a mean of 120 and a standard deviation of 10. So using the empirical rule, we're going to determine the interval of systolic blood pressures that represent the middle 99.7% of males. So the way to do that, draw yourself a normal curve, and the mean, remember, always goes in the center. So here's our 120. Now these lines on either side represent how many standard deviations we are away from the mean. So if the standard deviation is 10, that means that this value is going to be 130, and this value is going to be 110. And then I continue. So this will be 140, and this will be 100. And then finally, if I'm 3 standard deviations away, this will be 150, and this will be 90. Now we want to try and represent the middle 99.7% of males. So remember, when you're looking at one standard deviation, that's 68% of the data will fall there. If you're within 2 standard deviations, that's going to be 95% of the data. And remember, for 3 standard deviations, that's going to be the 99.7%. So it looks like 99.7%, that's almost all of the people, are going to have a systolic blood pressure from 90 to 150. So between 90 and 150. So that would be our range right there. So on delta math, the lower value will be the 90, and then the upper value will be the 150. And then you can just submit your answer like that. So there you go, we got it right. And it also shows you how to do it there too. All right, so let's look at a new problem. Okay, so when Camden runs the 400-meter dash, his finishing times are normally distributed with a mean of 65. So I didn't do this in the last question, but let's go ahead and write this down. So his mean, we'll say his sample mean for the moment, is 65 seconds. And actually, let's make that the population mean. Okay, and the standard deviation is going to be 1.5. Okay, so using the empirical rule, determine the interval of times that represent the middle 68%. Okay, well, again, the middle right here is going to be the mean, that's 65, and the standard deviation is 1.5. So that means this is going to be 66.5, and if I minus 1.5, I'll get 63.5. Now, because we're only after the middle 68%, remember when you're within one standard deviation, that's always going to be 68%. So we're looking for a range between 63.5 and 66.5 seconds. So let's go ahead and plug that in. So we have 63.5 and 66.5. There we go. Correctamundo. All right, let's try one more question. So yeah, let's do the reverse now. So when Brooklyn also runs the 400-meter dash, her finishing times are normally distributed with a mean of 76 seconds and a standard deviation of 3 seconds. So using the empirical rule, what percentage of the races will be finishing between 70 and 82 seconds? Again, use the diagram. The mean is always in the middle. There's 76. And then let's put on the other values using the standard deviation. So add 3, I get 79. Minus 3, I get 73. And then sorry about the pause there, and then we'll add 3 again. So we get 82, minus 3 again, we get 70. Now I could keep going, but remember the times that I'm interested in are 70 and 82, because that's in the question. Well, if it was between 73 and 79, that's within one standard deviation, so that would be 68%, but 70 and 82, that's within 2 standard deviations, so that's going to be 95%. So Let's go down there. So there you see within 2 standard deviations, it's 95%. So what we're going to do is we're going to type in 95, and I believe it'll probably want us to put in a percentage. Well, I'll tell you what, because it says percentage, let's just say 95, see what happens. If I get it wrong, I can just go back in and put a percentage. There we go. Didn't need to. And there you are. And again, you probably could also put in the percentage sign as well. So that's really all there is to it. There might be some harder questions, there might be some easier questions, but you're really just using those areas and those number of standard deviations from the mean. All right, good luck. If you have any questions, just reach out to us and let us know. Take care, everybody.